Happy New Year, guys. I wanted to start off this new year with a new video for you. This will hopefully close out the rest of our quadratic unit, unless I can think of anything else, but for the most part I think we've covered everything. As you recall, we've already talked about systems of linear equations, or linear functions. Now what we're doing is we're combining linear and quadratic. So, for example, we would have a parabola. So say we've got our parabola and just some line passing through it. And to solve it, really the solution is their intersection. Just like we had discussed with linear functions, the solutions were the intersections. If you think about it, we've kind of already done this or addressed this topic in a way. So what we have to think of it is that we've solved quadratic functions, we found the solutions or the roots where this line was actually my x-axis. Now the only difference is that this is no longer my x-axis. What it is just another line that is somewhere on my coordinate plane. So if you can imagine, rather than that being the x-axis, we can think of it as this being the x-axis. And so now we're not finding these roots anymore, we're actually finding the intersections of a parabola and just some other line that we happen to have graphed on there. So just to give you guys a general idea of what we're doing today, shouldn't take too long because we have the main concepts down already. So for example, we'll start with this first one. Example number 1. And so this one, let's say that we've got y equals x squared plus x minus 2, and then we've also got y equals negative x plus 1. So in this case, if I'm solving this system, I'm really finding the intersections between the two functions. What I want to do first, though, because sometimes these two things don't actually intersect. So there are scenarios where you've got maybe your coordinate plane, you've got a parabola here, and then let's say you've got a line passing over here. There is not going to be any type of solution because those two functions never intersect. So rather than taking the time to solve all of this first, what I want you guys to do is determine the number of solutions that are possible. If you end up with something that says no solution, then you know that those two functions do not actually intersect. So to determine the number of solutions, we've talked about this before, the number of solutions in a quadratic function is found by using the discriminant. Hopefully we remember this term. So if we use the discriminant, we can still use it with systems, and so this is how you would do something like that. Notice that both of these equations are y is isolated in both of these scenarios, so what I'm going to do is I'm going to set both of these equal to each other by using the substitution method. So I'm going to take this first part, so x squared plus x minus 2, and I'm going to set that equal to this, negative x plus 1. So here, in order to find the discriminant, what I need to do is get my quadratic function, or get it all equal to 0, as we've discussed before. So I'm going to add x to both sides, and then I'm also going to subtract 1 from both sides. So by doing this, everything on the right-hand side is set equal to 0. The left-hand side now becomes x squared plus 2x minus 3. So looking at this, we know that our discriminant is b squared minus 4ac. So my b here is a 2, so 2 squared minus 4a is 1, c is negative 3. So I've got 4, and a negative times a negative becomes positive 12. So really I have 16. If you recall, the discriminant tells us how many real roots we have. In this case, we're not talking about roots, we're talking about solutions, and the solutions are actually the intersections between these two functions. So this positive number, if you recall looking back on your notes, a positive discriminant tells me that I have 2 solutions. So I do know that this actually does have solutions. Now I'm going to work on finding the solutions. So first I'm going to show you how to find them if you are solving graphically, and specifically I will show you guys on the calculators. So if we take a look at what the calculators look like, say we're at the home screen, I'm going to go to calculate, or sorry, not calculate, I'm going to go to graph. So if I go to graph, I can easily type in my x squared, which is the first function, plus x minus 2, and then set that to graph. Now I want to enter my other graph, so we hit the tab button. There's my next function, which is negative x plus 1. So I see that these intersect at two different places. So if you recall, we can find those intersections by going to Menu, Analyze Graph, and Intersection. So it's going to ask me my lower bound, my upper bound. So there's my first intersection, negative 3, 4. So that means negative 3, 4 is my first solution. I do see that I have another intersection here. Not always the case. It could only intersect at one point, which in that case it would be the vertex. But here it doesn't intersect the vertex. It passes straight through, which makes this a secant line, if you recall from December's notes. So at any rate, we can find the next intersection by analyzing our graph again, picking our lower and our upper bound, and then you can see that the next intersection is 1, 0. So the two solutions to this system of equations would be at negative 3, 4, and then 1, 0. So hopefully that was not too difficult for us to understand. I don't think so, but let me know in class if there are any questions. Also, just recall that a discriminant, if you only have one quadratic function, a discriminant can be used to find the real roots. If you have a system, which we did in this case, then a discriminant can help us actually find these solutions, which in a way are the roots, but we're kind of taking a different perspective on these. So moving forward, I'm going to show you guys another example. Say you didn't want to graph it and you want to figure out how to do this algebraically, which I personally prefer. Here's a way to do that. So example number 2, this is going to be solving using elimination. And so it seems like most people preferred elimination, so that's what I'm starting with. I'll also show you substitution in just a second. So we've got y equals x squared minus 6x plus 9. And then we've got y plus 5x. Not plus 5x, I lied. So y plus x equals 5. So in this scenario, y is not isolated in both of these, which I want it to be isolated. So I'm going to subtract x from both sides here. So that'll leave me with y is equal to, sorry about that, negative x plus 5. What I can do now if I want to eliminate is I'm going to put these right on top of each other. So I'll use a different color to kind of show you that. So y is equal to x squared minus 6x plus 9. Y equals negative x plus 5. And so what I'm going to do to get rid of one of my variables, in this case I can see that I can eliminate the y's, is I'm going to subtract the whole equation from the top one. So y minus y leaves me with 0. X squared minus nothing leaves me with that x squared. 6x minus a negative x becomes plus x, so really I've got a negative 5x here. And then 9 minus 5 becomes a positive 4. So now this is the equation that I've got. It's still quadratic though, which means that I can either factor it or use the quadratic formula or complete the square, any of these methods that we had learned back in December. In this case, I can see that this is easily factorable, so I'm just going to factor that. So x minus 4 would be one factor, x minus 1 would be another. If I multiplied this out, I should get this equation. So in this case, I can see that my two solutions are going to be either x equals 4 or x equals 1. But I'm not done here. Before we would finish here, because we knew that these were my x-intercepts, in this case I'm not talking about x-intercepts, I'm talking about the intersection between this function and this original function. So what I have to do still is plug these into either one of these functions to find my corresponding y value, because I'm talking about a coordinate here. So if I take this linear function is the easier one to substitute into. So I'm going to say that y is equal to negative 4 plus 5. and that's by taking this x and plugging it right in. So I've got y is equal to -4 plus 5, which leaves me with 1. So that means that my solution, one of my solutions, is 4, 1. If I did the same thing with this x value, plugged it into that function, I've got y is equal to -1 plus 5, which means that y is equal to 4. So in this scenario, when x is equal to 1, y is equal to 4. So those are my two solutions. Again, you could graph it if you prefer, but this is a different method in case you do not prefer graphing. Finally, I'm going to show you guys how to find this solution using substitution instead of elimination, because I know some people prefer substitution. I'm still going to use the same equation as before because it's very, very similar in process. So if we've got the y equals x squared minus 6x plus 9, and then y plus x equals 5. What I'm going to do here is solve for a variable. As we can see, if I did the same thing as earlier, I have y is equal to -x plus 5. So now that I've got some variable or y isolated, I can substitute this expression in for y. So I'm going to write that over here, -x plus 5. So that's being substituted in for this y. And I know that that still equals the x squared minus 6x plus 9. So doing this, again, I could solve this by factoring, I could solve it by using quadratic formula, but first I have to get everything equal to 0. So I'd add x, subtract 5 from both sides, add x, subtract 5. So this ends up being 0, then I've got x squared minus 5x plus 4, which is really what we had earlier, if you recall. That's what I had here. So since I ended up with the same scenario, whether I substituted or eliminated, I can see that either method results in the same solution. So again, you could factor this, you could use quadratic formula, you could complete the square. Any method of your choice is going to get you the correct solutions. So to recall, our solutions ended up being 1, 4, and 1, 4, or 4, 1. So now you guys know how to solve systems of both linear and quadratic functions. Similar process when we get into cubic and other types, higher level functions, but for now this is all we need to know. You will have a quiz on Friday, January 8th regarding this information, so please be sure to let me know if you have any questions over this whatsoever, and I will gladly go over them. This is a big park topic, so you will want to make sure that you know how to solve these. Whichever method of your choice is fine by me, but just make sure you know how to do it, and also keep in mind there are some testing restrictions on the park, so you may not be able to use the functionality that we used on our calculators to find these intersections, so you will want to make sure that you know how to solve for these intersections algebraically. So make sure you either pick elimination or substitution, whichever method you prefer. Otherwise, let me know what questions you have and I will answer them. I hope you have a great day. See you at school.